Hi there, in this video we're looking at the surface area of cylinders. So the method for this is going to be exactly the same as all our other ones. We number up the faces and then we take it in turns to sort of find the area of each of those faces. So let's make a start. Well, we've got this circular face on top, we'll call that 1. We've also got a circular face on the bottom and we'll call that 2. And again, we're thinking in sort of these two make a pair because they're both the same shape. And then finally, we've got this curved surface that goes all the way around the cylinder, and we'll call that 3. So let's make a start at trying to work some of these out. Now 1 and 2 seem straightforward enough, but this curved surface 3 might cause us a few issues. But let's plough on anyway, and then we can sort of cross this bridge when we come to it. So the area of 1, well, 1 is a circle, so the area of a circle is pi times by the radius squared, and the radius of this circle is 5. So the area is equal to pi times by 5 squared, which is just 25 pi centimetres squared. And remember we said that number 2 was exactly the same, so that is for 1 and 2. Good. Again, at the end of the question we might type this into a calculator to round it, but I'm happy to leave it as 25 pi for now. Okay, let's have a bit of a look at 3 then. So 3 is a little bit trickier because, well, we don't know how to find the area of this curved surface. So what we'll do is we're going to have a bit of a look at how we find the area of a curved surface on a cylinder generally, and then we'll revisit this question and finish off to find the area of surface 3. Okay, so let's see if we can find a method or a formula to work out what the curved surface of the cylinder is. So the first thing that it's worth doing is sort of trying to visualise this and getting an idea of what it looks like. So what I've got for us is I've got a handy cylinder. Obviously you can find one of these around your home fairly easily, but it's just a normal cylinder and that I've cut so that I can unravel it. Okay, so if I unravel this cylinder, what shape is it that I get? Well, you should be familiar with this shape. It's actually a rectangle. So let's just draw that on. Okay, so the area of this curved surface is the same as the area of this rectangle. Now the area of a rectangle is length times by width, so wouldn't it be really nice if we could work out what the length and the width of this rectangle is in terms of h and r? At that point we're laughing, we can go back and do this and finish this example off really well. So let's first of all have a look at the slightly easier one. Let's look at h. So I've drawn h on the cylinder for us. So that's the height of the cylinder from top to bottom. Now let's see what happens to that length as I unravel it. Well, that height turns into the width of this rectangle over here. Okay, so look again, the height of the cylinder becomes the width of the rectangle. So let's draw that on. The height of the cylinder becomes the width of the rectangle, that's h. Okay, and now it would be really nice if we could sort of see what this length of the rectangle is in terms of the properties of the cylinder. And let's have a bit of a look then. So this time we'll start with the length because that's what we're after. So the length is the black line across the top. Now look what happens to that line as I roll it back into a cylinder. Well, it's the length or the distance around the top here, and that shape on the top is a circle, so that length becomes what we call the circumference. If you know your circles, you should be familiar with that, and the circumference of this circle on the top. So let's watch again. So the circumference of the circle, if I unravel it, turns into the length of the rectangle. So let's draw that on. So the length is equal to the circumference of the circle. So now we've got something we can use. because the area of the rectangle is equal to the length times by the width, which is equal to the circumference of the circle on the top times by the height of the cylinder. And now there's a few ways we can find the circumference. Okay, so the two ways we can find the circumference, let's just draw that on because it's that circumference we're after. The two ways we can find that, it's pi times by the diameter, if you're told the diameter, or the diameter is 2 times the radius, so you've got 2 times by pi times by r. So 2 alternatives you can use there. So it gives us sort of 3 versions of this formula down here. So we get pi d times by h, or we get 2 pi r times by h and h. So you've got sort of 3 versions. They all stem from this top one. So this top one is the one that I like to remember, because I'm fairly confident I can remember how to find the circumference of a circle. But if you'd rather remember one of these, then that's absolutely fine. Remembering one of these is a little bit more restrictive. Just if you're given the diameter, you then need to take that extra step to work out r. But either way, we've got our formula. Now we can go and apply this to our example question up here. Okay, so let's have a look then at finishing off this example. We'd found the 2 circular faces on the top and the bottom, so now we just need to find this curved surface here, which we've just seen is the circumference of the circle times by the height of the cylinder. So let's find the circumference first of all. So the circumference is 2 times by pi times by the radius. The radius in this case is 5, so had we been given the diameter, we could have said pi times diameter. Because we're given the radius, we'll work that out first of all. We'll do it this way. And the mass is exactly the same, so though if you wanted to use pi times diameter, you just double the radius to work out the diameter first. But that's exactly what we're doing. So the radius is 5, and 5 times 2 is 10 pi. So that's the circumference of the circle. That's, remember, the width of our rectangle when we roll this out. So now we just need to find the area by doing circumference times by height. So I know the circumference is 10 pi, and I know the height is 8. So altogether, my area, 10 times 8 is 80 pi. So now what we need to do is we need to add up 1 plus 2 plus 3 to get our final answer. So 1 was the area of the circle, which we worked out as 25 pi. 2 is the same, that's also 25 pi. And then 3 is this 80 pi that we worked out there. And so altogether, we get 25 plus 25 is 50, and plus my 80 is 130 pi centimetres squared. Again, we can type it into our calculator. So the best way to type it into our calculator is to use the handy pi button. So then we can type it in exactly how it looks on the screen. And then if we press equals, well, the first thing we get is something that's not very useful. It's just 180 pi. But if we press the SD button that we've talked about in previous videos, it turns it into a decimal, 565.49. There we go. So that is how you find the surface area of a cylinder.